Okay, so today we're going to start 1-3 Algebraic Expressions. So you should have your note-taking guide out, your math journal, and not your note-taking guide, just your math journal, and you should be doing the bell work on there. The bell work is right here in the square. So our objective today is to evaluate algebraic expressions and to simplify algebraic expressions. I'm going to give you 3 minutes to work the 3 problems in the box for our bell work. It says, use the order of operations to simplify each expression. The first problem is 3 divided by 4 plus 6 divided by 4. The second problem, in the numerator, you have 8 plus 5 times 2, all over 12. And number 3, you have 40 plus 24 divided by 8 minus 2 squared minus 1. Okay, I'm going to give you 3 minutes to do this, and the time starts now. There we go. Question? No. This is just recording what you see on the board and my voice. It's not going to record me personally. It just records what's across. See this red square on the screen? It's recording what's inside there and my voice, and it attaches them together in a video file. Yeah. Oh, I'm gonna.
Teachers, please excuse this interruption. Teachers, please lock your doors at the bell. The grace period for tardies has ended. Any student that is not in your class, when the bell rings, need to go to Trace and get a tardy pass. Do not allow students in your class after the tardy bell. Thank you.
Yeah, we're way past that. That was like day 2. And the note on the dress code, I can tell you this much. As long as I've been here, and I know Mr. Crace very well, if these few kids, so he said 15 he caught with sagging pants just in one cafeteria period, if the kids keep abusing the dress code that he's relaxed on, he's going to go back to formal dress code. So please make sure that you are in dress code every day. Okay? I've seen him pull things like that before, like over intercom. So that's what I thought he was doing a minute ago. Like the dress code, jeans are over. You're back to khakis. But he didn't. So make sure you, and keep your friends in check too. All right. You may use your calculator, but I do want you to try to do individual work to begin with, okay? If you absolutely are stuck and you can't get started, you can ask someone around you for like a head start. Just start, but try to do your own work, especially when it's these basic things. But I'm gonna go over it in a couple of minutes. So everybody but Araceli is here. Okay, that's time. And it looks like the air conditioner is still broken, or the heater's broken. It's just blowing cold air in the room. It was 60 degrees when I came in this morning, so I went and got my coat. So in case they don't get it fixed tomorrow, you might want to bring a jacket. I've had a little heater going in my room all day, but it really has only warmed it up to about 68. degrees, so it's still pretty cold. My hands are like ice cubes. All right, so does anybody remember how to solve mathematical expressions with mixed signs but no rules or reasons? Do you remember what rule to use to solve these? PEMDAS, yes. So PEMDAS is the rule. See, it didn't tell you do this, do that. It just gave you 3 divided by 4 plus 6 divided by 4. So what do you do first? It really makes a difference. You know, if you did the addition first and then divided that by 4 and then divided that answer by 3, it would be totally wrong. So how do you do this? And PEMDAS is the answer. PEMDAS. Is there anybody who hasn't done PEMDAS before? All right, so everybody's done it. That's great. So that means we're going to look through each one of these problems. And guys, this starts now and it goes all the way through the end of the year. We use PEMDAS in every single thing we do, to the point where you're not even thinking about PEMDAS anymore. You're just doing it. You're going, oh, parentheses, yeah, got to do that first. Oh, there's some exponents. Yep, that's next. You're just going to do it by second nature. So what we do is we look in this first one. Are there any parentheses? Nope. So I'm going to mark the P out. Are there any exponents? No. Is there multiplication? Nope. Is there division? Yes. And we have 2 division. We have the 3 divided by 4 and we have the 6 divided by 4. So when you have the division problems and you have more than one without any grouping symbols, you're going to just work them in order from left to right. So we're going to work the leftmost one first. So 3 divided by 4, that is 3 divided by 4, which we'll simplify in a second. And then we've got this plus. I'm going to keep that there. Now 6 divided by 4. 6 divided by 4, which we can simplify to 3 halves. Well, now let's go ahead and simplify this further. 3/4, if you did 3 divided by 4 on a calculator, you're going to get 0.75. And this is just one of those numbers that you won't even use a calculator anymore for. You're going to recognize, oh, 3/4 is 0.75, 75%. And 3 halves, that's 1.5. So 1.5. So now, when I look at this, I see sort of maybe money. So if I have 0.75 plus 1.5, we can stick a 0 after that. That's like money, isn't it? I recognize a little money pattern going here, 75 cents and $1.50. If I have $1.50 and I add 75 more cents to that, how much money do I have? $2.25. So 2 1/4, right? Because 2 of those quarters take that up to $2, and that leaves 1/4 left. So 2.25. So when you see things like that, get your mind trained to go, oh, I can work that like money. You know, dimes, nickels, anything like that. But I just wanted to point that out. So this comes out to 2.25. Okay? Any questions on that one? The next one, we have 8 plus 5 times 2 divided by 12. 8 plus 5 times 2 divided by 12. Was that correct? Did I transfer it right? I have problems transferring sometimes. 8 plus 5 times 2 divided by 12. Yes. So we're going to do our PEMDAS again. So I'll put it up here in the corner. PEMDAS. Some people say GEMDAS because parenthesis, the P part, is just a grouping symbol. And there's more grouping symbols than just a parenthesis. We have brackets that are grouping symbols. We have curly braces, right? So there's all more than just parentheses included in our grouping symbol. So just know when I say PEMDAS, The parenthesis stands for any grouping symbol. And there are none in this problem, are there? So that doesn't count. So next, exponent, there are no exponents. We do have multiplication. We have 5 times 2, and that's going to be 10. Right? Next we have division. Well, we've got a division. We're dividing all of this by 12. But what are we dividing by 12? Well, we could split it up and say 8 twelfths plus 10 twelfths. So you could do that and split it up. And now we've got 2 division problems, right? But in the end, you're going to have to combine it again. So I would elect to just go ahead and add, 8 plus 10 together, 18, and divide that by 12, okay? So 18 twelfths. There's our division now, okay? So that one was sort of a trick. Or you could have separated them and taken a lot of extra steps. But this is still good. So now, if we have 18 twelfths, can we simplify this? Well, we could divide them both by 2, right? So 18 divided by 2 is 9, and 12 divided by 2 is 6. So we could simplify it that way. Can I simplify this again? What are both of those divisible by? 3. So we could say 9 divided by 3 is 3, and 6 divided by 3 is 2. So now we've got 3 halves, and that comes out to what mixed number? 3 divided by 2 is 1 1/2. Okay, so you could write it as 1 1/2 or 1.5. Both of those are correct. Any questions? Don't forget to use your calculator, okay? Next, we've got this. Oops, sorry, that's really loud. 40 plus 24 divided by 8 minus 2 squared minus 1. So let's write our PEMDAS rules. Okay, do I have any parentheses? Nope. Do I have an exponent? Yes. We have 2 squared, which means 2 is the base. The square up here is your exponent. It means multiply the base together to itself this many times. So 2 times. So 2 times 2 is 4. So 2 squared comes out to be 4. Everybody good with that? All right, so now we've done our exponents. Now I'm going to rewrite this down here. 40 plus 24 divided by 8 minus 4 minus 1. All right, so our next thing is multiplication, but we don't have any multiplication. Then division, and yes, we have a division right there. 24 divided by 8. 24 divided by 8 is what? 3. I have one person answering all the time, guys. I need everybody. Okay, so let me rewrite it again. So we're going to have 40 plus 3 minus 4 minus 1. So now we've done our division. Now we go addition, subtraction. So let's do the addition. 40 plus 3 is 43 minus 4 minus 1. I'm just carrying those down. And now you could do 43 minus 4, which is 39. And then 39 minus 1 is 38. And that is your answer. Some of you might have just done the whole last line, that 40 plus 3 minus 4 minus 1. Some of you might have already combined that to -5, but I'm just trying to follow our rules. Any questions on that? All right, pretty easy, huh? Wouldn't it be great if the whole lesson was like that? And a lot of it is. A lot of it's this easy. Like I said, definitely the first chapter, just algebra review to get you warmed up. Our focus today is how can you represent mathematical phrases in real world situations with varying quantities. So as our lesson rolls on here, you need to think about this focus question, and by the end of the lesson, you should be able to answer it. So how do you represent mathematical phrases in real world situations with varying quantities? So varying quantities, that means amounts that can change, like the number of students in these desks each day change. The number of students present for each hour changes. That's a varying quantity. Total number of students. So how can you represent that in a real world situation? How do we represent that mathematically? That's what we're going to work on. So to begin, we need to learn how to model words with algebraic expressions. We've got multiple choice here. It says, which algebraic expression models the word phrase 7 fewer than a number t? And they give us these 4 choices. So let's look at this again. 7 fewer than a number t. Well, let's look at 7 fewer than a number t. And I use the pound sign a lot to represent the word number. So 7 fewer than a number t. So it means we're going to have t is going to represent something, and we're going to have 7 fewer than that. Okay, so there it is. 7 fewer than this number. Now, let's say, why wouldn't it be this way? 7 fewer than a number t. Well, let's see if these are the same. What if t represents the number of full tables every day in my room? So let's say I have 1, 2, 3, 4, 8. So if t equals 8, well, let's see. This would be 8 minus 7, which would be 1. And this would be 7 minus 8, which would be -1. Those are very different answers. They're opposites. And the fact that they're opposites was just, don't worry about that. So what I want you to realize is that they're different answers. So if we look at this, I'm trying to click the screen off. There we go. 7 fewer than a number t. It means we're starting with a quantity and we're going to be 7 less than that. Do you see that? 7 fewer. So if I had 8 tables yesterday and I have 7 fewer today, it's the initial amount, t, the number of tables, 8 minus 7. Okay? Everybody see that? That's probably one of the biggest hurdles to jump over in these word problems, and where I see the most wrong answers. So this is on your test though. So 7 fewer than a number t would be C, t minus 7. Any questions on that? All right. So tomorrow you will have whiteboards, and we're going to start doing work on whiteboards, and you're going to start showing me your answers so I can gauge where everybody's at. Are you getting it? Are you following along? Where is the class at as a whole? If we have something, we'll move on. If we don't have it, I'm going to have to reteach and get you caught up. So the whiteboards are really integral in our learning process. So tomorrow, make sure if there's not a whiteboard at your table for you that you come over here and get them, okay? And there's a whiteboard, an eraser, and a marker. So right now, I want you guys to work on this, and I'm going to go blow my nose because it's running like crazy. Which algebraic expression models the word phrase, and I'll highlight it, 2 times the sum of A and B. So work that on your journal, and I'll be right back. It does feel like it might be getting a little warmer in here. Okay, so 2 times the sum of A and B. Did anybody choose anything yet? Any answers? Yeah, what'd you pick? H? I would say you are correct. So good job. Now, how did she pick that if you didn't see? We have to pick apart those words. 2 times the sum of A and B. There we go. So 2 times the sum of A and B. So what are we saying here? We're going to take something and multiply it 2 times. Well, what are we going to multiply? The sum. So that means to add. So we're going to multiply something that we're adding up 2 times. What are we adding up? A and B. So there are our symbols. Now let's make it a little cleaner. So we don't use the dot when you've got a parenthesis there. So it's just 2 times A plus B. And that is correct. So that's 2 times the sum of A and B. So after I work these myself, I'll look at it again and say that phrase again while I go over it. So it would be 2 times the sum of A and B. And that totally makes sense, right? Does anybody have any questions? All right. So you'll have some of those on your test and your homework. So to model a situation with an algebraic expression, we have to do the following. We have to identify the actions that suggest the operations. So 2 times or 7 less than. Okay, so there's an action word there that says we're going to have to perform some math. Then after we identify those words, then we need to define 1 or more variables to represent our unknowns. So if it's a word problem, like how many, we have 6 tables less than yesterday, well, we're going to let T equal the total number of tables. That would be defining a variable. I defined the variable T to represent the number of tables. So identify, define, and the last thing we want to do is represent the actions using the variables and the operations. So then we put it all back together. T minus 7 means 7 less tables today than what our total yesterday. So identify, define, represent. Are there any questions? So the second problem, now we're going to move into word problems and modeling situations. In saving money, it says you start with $20 and you save $6 each week. What algebraic expression models the total amount that you save? Well, let's look at what they gave us again. We started with 20, so we know our total amount's going to be 20 plus and $6 each week. Well, to represent that, we need to represent the number of weeks. So let's just let W equal the number of weeks. And we have 6 each week, so it's going to be 6 times the number of weeks. So there's your mathematical expression, 20 plus 6W. So if I say, well, how much money do I have after 3 weeks? Well, W represents the number of weeks, so after 3, it would be 6 times 3. So 18 plus 20, which would be $38. Are there any questions? No? Okay, you guys are doing good. This is why I need my whiteboards, because especially with these silent classes, it gives me a true picture of, are we just shy or are we really hammering this out? Okay, you had $150, but you're spending $2 each day. Write a mathematical model for this situation. So do that now in your math journal. You had $150, but you're spending $2 each day. Okay, so write an equation for that, and I'll give you about 15 seconds. Okay? Would anybody like to tell me their answer? Yes. Perfect. So the first thing he did is he defined that he's going to have to be using a subtract because you're spending from your total. And he said, well, but we're talking about days, so I need a variable for the number of days. So let D equal days. So you've got subtract and let D equal days. So now put it to the math. You started with 150, so 150 minus $2 times the number of days. So very good. Very good. Does anybody have any questions? Yes. That's a really good question. The variable doesn't make any difference. If I wanted to say let a heart represent the days, then you can use a heart. But the best thing to do is just use something that's meaningful. So D for days, T for time. We'll do that a lot as we create these throughout algebra. So the more meaningful we can make that variable, the easier it is to work the problem, especially when they're like 15 steps to do. You don't want to lose track of, okay, T was time, V is variance. You're going to have all these different variables to work with. So the best thing to do is just keep it meaningful. So, the D for day was pretty good. And that's probably what you would see on the test also. But does it matter? No, as long as you can keep track of it. Did that answer your question? Okay. Any other questions? All right, so to evaluate, now we're talking about evaluate. To evaluate means we're going to give that variable, oh my goodness, I can't talk and write at the same time. So evaluate, E-V-A-L-U-A-T-E, evaluate. Okay? To evaluate means we're going to give that variable a number. We're going to give it a value. And then we're going to simplify it. So if I said, what did we have, 150 minus 2D? What if I said, how much money are you going to have in the bank after 3 days? Well, that means D. Now we're going to substitute 3 for D because it was 3 days. And now we're going to solve it. So 2 times 3 is 6. So it'd be 150 minus 6. And that would be $144. So you would evaluate it based on the value we give the variable. Okay? Any questions on that? All right, so let's look at our next problem set, to problem 3, evaluating algebraic expressions. It says, what is the value of the expression for the given values of the variables? So A gives us, and I think I blew this up over here. I did. Here's A. 7 times the sum of A and 4 plus 3B minus 8. And they say for A equal -4 and B equal 5. So when you get these, the first thing you should probably do is rewrite the original equation. 7 times A plus 4 plus 3B minus 8. Okay, so now we know that A is equal to -4. So everywhere I see an A, I'm going to replace it with -4. And everywhere I see a B, I'm going to replace it with 5. Okay, now I'm going to rewrite it. 7 times -4 plus 4 plus 3 times, because when they're right next to each other, it's a multiply. We just don't write the dot in there. So 3 times 5 minus 8. So now let's simplify. Using our PEMDAS rules, parentheses first, right? So -4 plus 4, well, those are opposites, and we know that their sum is 0. And here's the next okay, so we had parentheses, exponents, multiplication, so multiplication is next. And we have 3 times 5, which is 15. So let me rewrite this. 7 times 0 plus 15 minus 8. Well, we're still on multiplication, so 7 times 0 is 0. Okay, and now we're just down to 0 plus 15 minus 8. Well, that might as well not even exist, right? So we're down to one operation, so we can actually just do that instead of going down the PEMDAS, because there's just one thing left. Well, 15 minus 8 is 7, and that's our answer. Any questions on that one? I always have you put a box or circle your answer, your final answer, and you will see me a lot of times put a slash through a 7 so it doesn't get confused with a T or a letter. And I will often put a slash through a 0 so you don't confuse it with an O. And I will sometimes do that on 9s, so you know that's a 9 and not a Q. Okay. So I put the slashes through the numbers, not the letters. But always put a box or a circle around your answer. And then when I grade it, I will always do a check for good or an X for wrong. And when we grade them, you will do the same thing. If you were grading your papers, you would put a check for correct or an X for wrong. And if it's wrong, you're going to always write in your correct answer. Okay. Any questions so far? And we'll hit that again. Okay, let's look at the next problem. There were 2 parts to this. Now they have x over 4 plus y squared for x equal 1 and y equal 1/2. Let's see if I can blow this one up. That is so loud. All right, so here we are. So we're going to start with rewriting the original equation, x over 4 plus y squared. And we're going to replace x with 1 and y with 1/2. So let me rewrite that now. 1 over 4 plus 1/2 squared. Is everybody good? So now do your PEMDAS, parenthesis. Well, there's nothing inside the parenthesis to do. So next is exponents. So here we are. We've got 1/2 squared, which means take this base of 1/2 and multiply it to itself 2 times. There it is. 1/2 times 1/2. Well, 1 times 1 is equal to 1, and 2 times 2 is equal to 4. So 1/2 squared is 1/4. So now we have 1/4 plus 1/4. Now, when adding fractions, remember, you keep the base of 4 and you add or perform the operation on the numerators. So 1 plus 1 is equal to 2. So 2/4 is still not simplified. 2/4 is, they're both divisible by 2, right? So 2 divided by 2 is equal to 1, and 4 divided by 2 is equal to 2. So your final answer is 1/2. 0.5 is also acceptable, or 0.5. I never write the leading 0. I always just do 0.5. Okay, any questions on that one? Very good. We're moving right along. So let's look at our next problem, problem 4. Writing and evaluating an expression. In football, a touchdown, TD, is worth 6 points. So I'm going to go ahead and just sort of copy what I think are the main facts. Touchdown is 6 points. So that one I've got notes on. An extra point kick, an EPK, is worth 1 point. Okay? And a field goal is worth 3 points. Okay, so I've got that first sentence out of the way. Now, what do they want to know? What algebraic expression models the total number of points that a football team scores in a game? So that's the first part. So first we're just going to create the algebraic expression to total the points, and then we'll come back to that after that. So if I have the total number of points in a game, let's just choose one variable for each one of these. Let's let T be the touchdowns, let's let K be the kicks, and F be the field goals. So if I'm going to get the total number of points in a game, I'm going to have 6 times the number of touchdowns, so 6T, plus 1 times the number of extra point kicks, plus 3 times the number of field goals. So there it is. There's your mathematical expression. And it doesn't have to be my variables. You might have chosen an E for extra point kick. But as long as it's something meaningful that you can go back and understand. These are what I chose, T, K, and F. Now, the second part says, suppose a football team scores 3 touchdowns. So I'm going to write right over this. 3 touchdowns. So I'm going to substitute 3 for T. 2 extra point kicks, so 2 for K. And 4 field goals, so 4 for F. So there they are, and we're going to multiply all those. So it's going to be equal to 6 times 3, 18, plus 1 times 2, which is 2, plus 3 times 4, which is 12. So 18 plus 2 is 20, plus 12 more is 32. So we would have 32 total points. Are there any questions on that one? All right, let's move forward. There's a couple of terms I want to talk about. Term, and one of the terms is term. So if we talk about mathematical terms, an expression that's a number, a variable, or a product of a number and one or more variables is a term. So let me show you. This is a term, this is a term, and this is a term. Okay? So let's read those words again. An expression that is a number, a variable, or a product in a product of a number and one or more variables is a term. So there's the product of a number and more than one variable, x squared and y, right? So all of these are term. terms. If I had this in a mathematical expression, clean this up a little bit first. There we go. If I had these in a mathematical expression like this, we would call this number 5 the first term. This is the second term. And this is the third term. And the sign to the left of the term goes with it. Okay? So, well, we know that's a plus because there's no negative sign in front of it, right? And if there's no sign, it's assumed to be positive. And here, and if there's no coefficient to your variable, it's just always understood to be 1. Right? And then the third term is here. So, first term, second term, third term in this expression. And that's an algebraic expression because it has both numbers and letters, right? So, there's two parts to terms that share numbers and variables, like a 5x. Let's make it a negative 5x. Okay, this is your variable part, and this is the coefficient of the variable x. So we could say negative 5 is a coefficient to x, or 3 is the coefficient of x squared y. Okay? Now, a lot of times you won't see just one term. You'll see several terms in an equation. So you'll have like a 5x plus 2y plus 3x minus y. So if you look at these, you might want to just go, oh, well, 5 plus 2 plus 3 minus 1, xy. Just make it all one thing. But you can't combine them because they're not like terms. So what is a like term? And I've got a definition in the next page. So like terms have the same variables raised to the same powers. Same variables raised to the same powers. So let's look at this guy. Let me blow it up. So if you notice, I've got an x squared and an x squared, 3x squared plus 5x squared, plus 9y cubed z, plus 2yz, minus 4y cubed z. So it said like terms have the same variables to the same powers. Well, the same variables, okay, here's an x to the second power. So there's also an x to the second power. So it's same variable, same power. So these are like terms. That means that you can combine these. That is like saying 3 plus 5 times x squared, which is 8x squared. I don't expect you to write that middle step, but when you see this, you need to know, oh, that's 3 plus 5 x squared, 8 squared, 8x squared, excuse me. All right? And same, okay, do I have any more y cubed z's? There's those variables and powers. And it has to be exact, y cubed z. And we do, we have one right here, a y cubed z. So these are like terms, and that means that we can combine the positive 9 minus 4 y cubed z. So it would be 9 minus 4, which is 5 y cubed z when you combine them. So we had a, let's see, 8x squared plus 5y cubed z, and then we're left with this lonely little 2yz. And he had no like terms, so he's just nothing you can do but make sure you keep it in each line as you simplify and go down. This is as far as you can simplify. You can't combine anything else, so this becomes your answer. All right, so one thing I wanted to point out, where was that? Oh, I erased it, I think. Did I? Nope, I didn't. Let's look at this guy now and simplify it. Well, we've got an x and an x. So 5x plus 3x, that's going to be 8x. And then I have a y and a y. When you are missing a coefficient, it's always understood just to be 1. Okay? So just add your 1 there till you get used to seeing it without the 1, so you don't make those mistakes. So this is going to be 2 minus 1 y, which is 1 positive 1 y. And if you leave your answer like that, I'm not going to count it off, but it's more correct. We don't write 1. Just like I didn't write a positive sign in front of that 8. We knew it's understood to be positive. Same thing when you see a single variable, it's just understood to be 1y. And something else I'll point out, everything we do has a power. Everything we work in, that's 8 to the first power, x to the first power, y to the first power. When there's no power listed, it's just assumed to be 1. All right, so there's another little fun fact for you. All right? We just don't write anything to the first power because it's just itself, right? 8 to the first power is 8, x to the first power is x, and y to the first power is y. All right, so I'm not going to go through all these, but I'll leave them on the video for you to look at if you want to. It's just about all the definition of subtraction, divisions, and grouping and opposites and things that we've already covered. But if you go home and go over this on the video and you have a question, don't hesitate to bring it back to me. But we are running out of time here. So the last problem, simplifying algebraic expressions. Combine like terms, what's the simplified form of each expression? The first one gives us 7x squared plus 3y squared plus 2y squared minus 4x squared. And I think, did I write that? There it is. Okay, so here it is. Now let's combine our like terms. So what do we have? We have an x squared, and there's another x squared. So remember, the sign to the left of it goes with it. So it's going to be 7x squared. It's probably better to put them in order first. Minus 4x squared, so those are done. Now we're just left with 2y squareds. So we have a plus 3y squared plus 2y squared. Now they're in order where we can easily see how to combine them. So 7x squared minus 4x squared, well, that's 7 minus 4, which is 3x squared, plus 3y squared plus 2y squared, that's just 3 plus 2, which is 5y squared. And that's simplified. That's as far as you can take that. Okay? Any questions? This should be review, and hopefully you'll find it really easy. Back to our focus question, how can you represent mathematical phrases in real-world situations with varying quantities? We use algebraic expressions to represent the phrases or situations that have varying quantities. So algebraic expressions, and that's what this whole lesson was about today. All right, so your homework tonight, and you can work for the next 3 or 4 minutes if you want, and put up the last minute. Work all your odd problems. The odds are 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, and 27. It's all numbers that are not divisible by 2. That's what an odd number is. And I learned that, I think it's in the Hispanic language, there's no word for even or odd in math. So, kids, is there? I've been told over and over, and by even our Spanish teacher, that there's really not a word that represents odd numbers or even numbers. But we could be wrong. So the odds are just the ones that are not divisible by 2. All right, any questions? Okay, this will be due tomorrow when you walk in. Yes? Oh, always see that our lesson is 1-3. Practice, and it's always the form K. Practice form K, the front and the back. Always. I don't do page numbers because we're all on different page numbers. Yes.
Can I turn mine in right now?
We'll turn them in tomorrow with the class. If you turn it in now, it's most likely going to get shuffled in an odd pile that you won't get graded with the class. But good job. That's what I used to do in high school. My teacher would teach, Mr. Fisher at Jinx. I'd walk in every day and he'd call me Sunshine. Hello, Sunshine. Probably because I was always trying to sleep. And but he loved me, and I loved him back. He was a good teacher, and I always had my assignment done every day before he was through teaching. Then I try to go to sleep. Hello, Sunshine. All right. Any other questions? All right. Thank you, and that concludes our lesson.